Okay, so imagine this for a moment. You're looking out at the solar system, a place that for a long time we assumed was mostly silent, cold, and lifeless. A few rocky planets, a handful of frozen moons, and endless emptiness between them. But the deeper we look, the more that quiet picture starts to break apart. Number 10. Ceres and the Bright Secret of the Asteroid Belt. In 2015, NASA's Dawn spacecraft approached the largest object in the asteroid belt, the dwarf planet Ceres. What it discovered immediately confused scientists. Across the dark, rocky surface were more than 130 intensely bright spots, shining like tiny beacons against the gray terrain. The most striking cluster sat inside Okator crater, where a region roughly 15 kilometers wide reflected sunlight almost 40% brighter than the surrounding landscape. When scientists analyzed the material causing that brightness, the answer was unexpected. The deposits were sodium carbonate, a salt that forms through hydrothermal processes. On Earth, these minerals appear around hot springs and geysers, where water circulates underground, dissolves minerals, and eventually evaporates. But Ceres was supposed to be dead. For a body only about 940 kilometers wide, it should have cooled and frozen solid billions of years ago. Yet the deposits suggested something very different. At some point in the relatively recent past, liquid water moved beneath the surface. And the mystery didn't end there. Repeated observations revealed something subtle, a faint haze appearing and disappearing above Okator crater during Ceres' daylight cycle. The most likely explanation is sublimation, water vapor slowly escaping from beneath the crust. Gravity measurements from the Dawn mission confirmed the possibility. Beneath the surface, Ceres likely contains pockets of salty brine, possibly remnants of a subsurface ocean. And where you have liquid water, minerals, and chemical energy, you have the ingredients life needs. Hidden inside the asteroid belt, in a place once thought completely frozen, Ceres may still contain warm, wet environments deep underground. Number 9. Titan's hidden ocean beneath methane seas. Saturn's largest moon, Titan, is already one of the strangest places in the solar system. Its surface hosts lakes and seas of liquid methane, rivers carved by hydrocarbons, and a thick orange atmosphere richer than Earth's. But Titan's most important secret lies far below the surface. Data from the Cassini spacecraft revealed that beneath Titan's icy crust sits a global ocean of liquid water, buried roughly 55 to 80 kilometers deep, and it's enormous. This hidden ocean may be 250 kilometers deep, containing more water than all of Earth's oceans combined. What makes Titan especially interesting is its chemistry. The ocean water is mixed with ammonia, which acts like antifreeze, preventing it from freezing solid in Titan's extremely cold environment. This also means the ocean may be in contact with Titan's rocky interior, allowing chemical reactions between water and minerals. Above that ocean is an atmosphere packed with complex organic molecules, the carbon-based building blocks of life. These organics slowly rain down onto the surface over billions of years. If cracks or fractures in the ice allow those materials to seep downward, Titan could be delivering organic chemistry directly into a warm ocean below. Even more intriguing, Titan is protected by Saturn's magnetosphere and its own thick atmosphere, shielding it from much of the radiation that bombards other moons. That means its ocean could have remained stable for more than 4 billion years. A vast underground sea, constant chemical inputs, and extraordinary stability. Exactly the kind of environment where life might quietly emerge. Number 8. Mars' subsurface brine lakes. For decades, scientists believed that liquid water could no longer exist anywhere on modern Mars. The surface is too cold, the atmosphere too thin, and the pressure too low. But in 2018, researchers using radar data from the Mars Express orbiter made a shocking discovery beneath the Martian south polar ice cap. Buried 1.5 kilometers below the ice, they detected the unmistakable radar signature of liquid water. The lake stretches roughly 20 kilometers across. The problem is temperature. At that depth, conditions drop to about negative 68 degrees Celsius, far below the freezing point of normal water. So how could it remain liquid? The answer is salt. The water appears to be an extremely concentrated brine, saturated with salts like perchlorates. These chemicals dramatically lower the freezing point, allowing liquid water to exist in temperatures that would normally freeze it solid. In 2020, follow-up studies suggested the presence of 3 additional lakes nearby, potentially forming a network of underground brines. These environments are extreme, dark, cold, highly saline. But on Earth, similar places still host life. Microbes thrive in Antarctica's Don John Pond, one of the saltiest bodies of water on Earth, where temperatures plunge far below freezing. Deep sea brine pools in the Mediterranean also support microbial ecosystems. If life ever appeared on Mars billions of years ago, when rivers and lakes flowed across its surface, these buried brines might be its final refuge, protected beneath the ice, hidden from the radiation that sterilizes the surface, waiting in the dark. Number 7. Triton's cryovolcanic underworld. When Voyager 2 flew past Neptune's largest moon, Triton, in 1989, it found something no one expected: active geysers erupting from the frozen surface. Jets of nitrogen gas were blasting 8 kilometers into the sky, scattering dark particles across the landscape. This was astonishing. Triton's surface temperature sits around negative 235 degrees Celsius, making it one of the coldest places ever measured in the solar system. Yet somehow, something inside the moon was still active. Triton's strange retrograde orbit suggests it wasn't born around Neptune. Scientists believe it was originally a Kuiper Belt object, similar to Pluto, that was captured by Neptune's gravity long ago. That capture likely created intense tidal forces, flexing Triton's interior and generating heat. Many researchers now believe that beneath Triton's frozen crust lies a subsurface ocean of water mixed with ammonia, kept liquid by internal heating. And Triton's story may not be finished. Its orbit is slowly decaying. In about 3.6 billion years, it will cross Neptune's Roche limit and be torn apart by gravity. But right now, in this brief window of cosmic time, Triton may be warm enough inside to support liquid water, a captured world, temporarily alive beneath the ice. Number 6. Miranda's chaotic interior. When Voyager 2 visited Miranda, a small moon of Uranus, scientists expected to find another frozen, cratered ball. Instead, they found something that looked almost broken. Miranda's surface is a chaotic patchwork of terrains, as if pieces from different worlds had been stitched together. Massive structures called corona, enormous oval regions hundreds of kilometers across, show strange ridged patterns unlike anything seen elsewhere. And then there's Verona Rupes, a cliff that drops 20 kilometers, making it the tallest known cliff in the solar system. Features like these require enormous internal energy to form, yet Miranda is only 470 kilometers wide. The leading theory suggests that in the past, Miranda was locked in orbital resonance with nearby moons. That resonance caused intense tidal heating, flexing Miranda's interior and generating warmth. Some of that heat may still remain today. If it does, Miranda's interior could contain isolated pockets of liquid water trapped within a fractured maze of ice, a hidden labyrinth deep beneath one of the solar system's strangest moons. Number 5. Iatopus and the Impossible Ridge. When the Cassini spacecraft imaged Iatopus, scientists noticed something bizarre. Running exactly along the moon's equator is a ridge stretching 1,300 kilometers long, rising up to 20 kilometers high. It looks almost like a seam running across the entire moon. No known geological process fully explains how it formed. One theory suggests that Iotopus once had a ring system. As the ring material slowly fell back to the surface, it may have piled up along the equator. But this idea struggles to explain the ridge's extreme height and sharp structure. Even stranger, Iotopus has a dramatic two-tone appearance. One hemisphere is dark as asphalt, while the other is bright as snow. The ridge sits mostly within the dark region, hinting that the two mysteries might be connected. Scientists continue to search for a natural explanation, but for now, Iotopus remains one of the most geometrically strange objects in the solar system.
Number 4. Europa's Ocean Fortress. Jupiter's moon Europa may be one of the most promising places to search for alien life. Beneath its icy crust lies a global ocean containing more water than all of Earth's oceans combined. That ocean exists because Jupiter's gravity constantly flexes Europa's interior, generating heat through tidal forces. The ice shell above, likely 10 to 30 kilometers thick, acts as a protective shield, blocking the intense radiation that bombards the surface. Below that frozen barrier, the ocean may remain warm and stable. In 2012, the Hubble Space Telescope detected enormous plumes of water vapor erupting from Europa's surface, reaching heights of 200 kilometers. These plumes may originate from the ocean below, carrying salts and minerals with them. And if Europa's ocean floor contains hydrothermal vents, similar to those on Earth, then the moon may host the same type of environments where life first emerged on our own planet. Dark, warm, chemically rich, a hidden ocean, evolving in isolation for 4 billion years. Number 3. Enceladus and the Smoking Gun. Saturn's small moon Enceladus shocked scientists when the Cassini spacecraft observed enormous plumes erupting from its south pole. These geysers spray water vapor, ice particles, salts, and organic molecules hundreds of kilometers into space. Cassini flew directly through the plumes and analyzed their chemistry. The results were extraordinary. Scientists detected molecular hydrogen, a key sign of hydrothermal reactions between water and rock, the same process that powers ecosystems around Earth's deep-sea vents. They also found tiny silica particles, which only form when hot water interacts with rock at temperatures above 90 degrees Celsius. Together, these discoveries suggest that Enceladus hosts active hydrothermal vents on its ocean floor. Liquid water, organic molecules, chemical energy. These are the exact ingredients that allowed life to begin on Earth. Enceladus may already have them all. Number 2. Ganymede's Magnetic Sanctuary. Jupiter's moon Ganymede is the largest moon in the solar system, even bigger than Mercury. But what makes it truly unique is something no other moon possesses: its own magnetic field. This magnetic bubble shields parts of the moon from Jupiter's intense radiation, creating a relatively safer environment. And beneath Ganymede's thick ice lies another astonishing discovery: a global ocean about 100 kilometers deep, buried roughly 150 kilometers below the surface. This ocean may contain more water than all of Earth's oceans combined. Protected by thick layers of ice and isolated from radiation, it could have remained stable for over 4 billion years. If life exists there, it may represent a completely independent origin of biology, evolving in isolation within Jupiter's system. Just 628 million kilometers from Earth. Number 1. Venus and the life in the clouds. For most of modern science, Venus was considered completely uninhabitable. Its surface reaches 465 degrees Celsius, hot enough to melt lead. The atmospheric pressure is crushing. The clouds are made of sulfuric acid. But something strange happens about 50 to 60 kilometers above the surface. At that altitude, the temperature ranges from 0 to 50 degrees Celsius, and the pressure is similar to Earth's. In 2012, astronomers detected traces of phosphine gas in Venus's atmosphere, a molecule that on Earth is primarily produced by anaerobic microbes. The discovery sparked enormous debate. Some scientists argue the signal may be an observational error or an unusual chemical process we don't yet understand. But the possibility remains. Because Venus's clouds also contain mysterious particles that absorb ultraviolet light, forming dark patches that have never been fully explained. Some researchers have even suggested they might be microbial colonies floating within the clouds. If that were true, it would mean life can survive in environments we once thought completely impossible, floating in acid clouds above a molten planet. And if life exists there, then the nearest alien biosphere in the universe might be right next door. And remember, the universe doesn't reveal its secrets to those who rush. It reveals them to those who know how to look. Subscribe and keep listening to the silence.